Morning to you all. Today I gonna Chug, a student of class 11th A, Balbhavan Public School, is going to present my idea in front of you all, which name is Barriers to Signal Strength of a Wi-Fi. And it is under the sub-theme of Science with Fun, and I am under the mentorship of Miss Nitika Khandelwal ma'am. Have you ever suffered from poor Wi-Fi reception for your smartphones, tablets, and many more? Certainly, yes, because many materials can actually block your Wi Fi signals, and that could be a part of your problem in increasing that. So, in this science project, we will do experiments to find out which materials can cause the biggest drop in the signal strength from a wireless router and measure how much different materials affect the signal strength of a wireless router. Now, before I start with my intro part, I would like to share some information about Wi-Fi or wireless fidelity with all of you. Wi-Fi is the common name for a type of communication that allows electronic device to exchange data or to connect internet wirelessly. Wi-Fi devices do this using radio waves, which are the type of electromagnetic radiations. One such electromagnetic radiations with which we all are familiar is visible light. Each part of the spectrum has different frequencies or number of waves per second. Frequencies is measured in hertz, whereas Wi-Fi devices operates at either 2.5 Hz or 5 GHz. Each type of radiation has a different frequency. Humans are most familiar with the visible light since that is what we can see with our naked eyes. Electromagnetic radiations can be attenuated and weakened as it passes through different materials. For example, visible light can pass through materials like air or clean glass as they allows the visible light to pass through them easily. But some materials like water or tinted glass will let a few of light to pass through them, and materials like wood or metal would completely block the visible light. Today, we will understand that whether this happens with all the waves or not, and we will also test the ability of different materials to block Wi-Fi signals from a wireless router. Now, we have to download and install an app or a program for our wireless devices so that we can measure the signal strength of a wireless connection. Some programs provide a signal quality rating on a scale of 0 to 100, but ideally we should be looking for a program that provides us the measurement in decibel milliwatts. We have to be familiar with the program before finally using it so that we can be in handly. After that, when we have recorded that measurements, we have to create a table as shown in the next slide. So you can see the table and then we will move ahead and get to know about the factors affecting location. But before that, let me tell you that the low value of dBm indicates that the signal strength is very good. So location should be consistent and the location should have be in the same room as your wireless router, that is several meters away from it, and secondly be in the same height of the floor as your wireless router. Now we have to determine how we will arrange the test materials for each trials, and the most important thing is to keep the setup same for each trial of the experiment. A part. Make sure that the test materials are close enough as possible to the router without touching the router. And B part. We could have volunteers stand off to the side of the material or the router so that he could check that again and again and the router doesn't falls. So here is the figure 2, which you all can see. There's example of a diagram of experimental setup, and we can notice the following key points. That is, the test material is close enough to the router but not touching it. Secondly, the router and the wireless devices are at the same height. And thirdly, the person doing the experiment is not standing between the router and the wireless devices. So finally, start this by measuring the signal strength with no blocking material. And this is the experiment's control. Measure the signal strength in dBm and enter the value in the trial 1 and repeat this 2 more times to form a total of 3 trials. Set up your first blocking material and then check out the readings. And remember that we do not have to remove or change the position of the blocking material or wireless device in between trials. At last, repeat the same step for each of the remaining blocking materials. From this experiment, we conclude that there are many ways to find Wi-Fi strength. Using dBm or decibel milliwatts measurements is the least complicated and most common attenuated method. We also got to know that at minus 30 dBms, signal is very good, whereas signal strength of some blocking material were of minus 80 dBm to minus 90 dBm. We have also seen that the aluminium foil is very good in case of signal strength, but other are bad conductors. So, thank you for being a patient listener, and I hope that you all learned a lot from this.